Good morning, students. In today's class, we are going to discuss about the text classification using the Python libraries. So for this text classification, we are going to use a data set which is consisting of 20 news group data set. And first of all, we are trying to pre-process the data, pre-processing our text data, and then we'll give the data for the classification purpose. And finally, we evaluate the performance of the model. And here we are going to use the libraries like sklearn, pandas, and numpy. So first of all, we have to set the environment for that. So I'm installing, I make sure that all the libraries are installed in my Google Colab environment. So I'm installing all the libraries as we discussed earlier sessions also. And finally, I'm importing the libraries which are required for my execution of the program. So we have imported all the libraries which are required for us. Then I'm loading my data and I'm preparing my data set for the evaluation of the model. So first of all, I should know about my data set, that what data set I'm going to use here. So we are using here 20 news group data set, which is a top popular data set for experimenting with the text classification and natural language processing techniques. This dataset is consisting approximately 20,000 news group documents and which are partitioned across 20 different news groups. And we can say as it is having 20 different news groups, so this could be an ideal data set for classification of text data, and every news group correspond to a particular category. So every news group is representing one category of your data set. Okay, so total we are having 20 news group here. And these categories of news groups are divided into variety of range, like it belongs to the religion, it belongs to the politics, to computer hardware, to software, sports related information, and all these informations are available in this particular data set. So this is all about my data set. So first of all, what I have to do, I have to load the data set. I'm loading my data set, I'm fetching my data set. I'm taking all the subset of my data set which are available, and I'm dividing my data into X and Y. So X is representing the X is representing the input features, and here Y is representing the label of my data or target variable of my data. And as we know that once we load the data, we have to split the data into training and testing. So we are splitting the data into training and testing. My 30% data I'm using for testing purpose, and remaining 70% data we are using for training purpose. Now, as we are working with the text data, so we should know some basic terminology which we are going to use in further discussion. So, as we know that data set we cannot give directly to the model. Okay, so because data set will be a raw data which we cannot give directly to the model, so I have to perform some pre-processing on that. So whenever I'm talking about the text data, I should know some of the terminology. I should know what is token. I should know what is stop word, what is embedding, what is TF, what is TF ITF, all these things we should know. So what is token first? So suppose I have a terminology. I love machine learning. So every word is a token for me. Every space, every full stop, comma, everything is a token for me. Okay, so this is called tokens. Now the other terminology which we are using here terminology term frequency, stop words, term frequency, IDF score, all these things we are using here. So we'll discuss one by one what exactly, then we'll discuss about the program. So what exactly the term frequency is? It is used to measure the frequency of a terms appear in a document. Suppose I have a document, I want to know that how many times a word A appear in my document. So I can represent through the term frequency. So the higher the frequency, the term that particular term is more important. Suppose in my document, machine learning is repeated 10 times and deep learning is repeated two times. So machine learning is a significant word for me in my document. So this, if I want to know the significance of a word, I should calculate the term frequency of every word which is appear in the document. So the higher the frequency, the more important the term is. The same way we have another terminology which is called inverse document frequency, which is used to measure how important a term is by accounting of its occurrence across all the documents which are present. We are calculating across all the documents. The rarer the terms means that it will get the highest score. The term which is having the rare term which will get the higher score here. So what is TF-IDF in that case? We know what is TF, we know IDF. So we want to know what is TF-IDF score. So TF-IDF score is nothing but the product of your TF and IDF. If you multiply both, it will get the TF-IDF score. So it will give you a balance. We can say it balances the term frequency in a document and its rarity across all the documents. So term frequency we are calculating in a single document. Inverse term frequency we are calculating in all the documents. So if I multiply both, I'll get TF-IDF score, which will give me a balance between the term frequency in a document with its rarity across all the documents. So for that reason, we are calculating TF-IDF. Now the question is, what is stop words? Stop words are nothing but your comma, semicolon, all these are called stop words. So, commonly used words that are often removed during the text pre-processing are called stop words. Okay, A, N, D, all are also what for me a stop word it is. So, I have to remove all these stop words from the data. Okay, so commonly used words that are often removed during the text pre-processing are called stop words. So now the question is why I'm calculating TF-IDF. So it will reduce the influence of common words. If I'm calculating a TF-IDF, I can reduce the influence of common words, that word which are common across many documents like and, is, a, the. I can remove those directly because there is no significance. It's not giving me any important information. These are just a stop words for me. They're not giving any significant information to me, so I can remove such type of words which are common across the documents. And it is also highlight the important terms, the rare terms that are significant to a particular document, which are getting the highest score. I can get through the TF-IDF, and I can give the more importance to those terminology. Okay, so these are the some terminology which we are using during the pre-processing. Okay, so now we will learn how to do the pre-processing. Okay, so first what we are doing, we are converting text data into TF-IDF features. So what we are doing, I'm trying to convert whatever text data is there. I'm trying to convert the TF-IDF feature of that particular data. So what I'm using from sklearn, I'm importing the features. I'm importing the TF-IDF vectorizer. So what this will do, it will import the TF-IDF vectorizer class from the sklearn feature extraction text module. And what it is, this TF IDF vectorizer, it's nothing but it is a tool which is used to convert the collection of raw document into the form of matrices. I have a document which is unstructured. Now I want to convert into the matrix of TF IDF features. So I'm using TF IDF vectorizer. Okay. After this, I'm using this particular line of code. So what I'm doing with this particular line, I'm creating an instance for TF IDF vectorizer with the parameters where I'm using a parameter stop word equal to English. So what I'm saying with this particular line, I'm telling the vectorizer to ignore the common words which are commonly used in English language. So you can mention the language. So suppose there are different common words which are used in Telugu, which are used in English or any other language. So you have to specify for which language you want to ignore the common words. So we are trying to ignore the common words of English, which is the, and, is, are, all these common words, which are not often useful for the representation of the main content. So I'm removing those stop words from my document, and I'm keeping the results into vectorizer variable. Fine. And then finally, I'm transforming my data I'm fitting my data and transforming my training data. Clear? Now what I'm doing with this particular line of code, I'm converting the text. Now I have done this for the training. The same way I have to do for the test data also. So with this particular line of code, what I'm doing, I'm trying to convert the test text data into a sparse matrix of TF-IDF features using the vocabulary and statistics computed from the training data. So whatever vocabulary and statistics I have computed for the training data, I'm using that information and I'm trying to convert the text data into a sparse matrix of TF-IDF feature using that particular vocabulary. So in that way, I'm performing the pre-processing. Once the pre-processing has been done, now I'm training I'm giving this data to the Navy-based classifier for classification purpose. So we know how Navy-based classifier works. We discussed in the previous classes also that how Navy-based classifier works. So we are using here multinomial Navy-based classifier here, and I'm giving the training data and training data and corresponding label to this, and I'm fitting my model. So once the model has been fit, now I'm trying to predict the result on test data. So in doing the prediction, I'm just giving the data, not the label, and I'm giving the keeping the result into Y prediction variable. And now I want to evaluate the performance of my Navy based classifier. So as we know, to evaluate the performance of the classifier, I can use the parameters or evaluation matrix, which is accuracy. I'm using here accuracy with test data and the predicted data. I want to print the classification report, so I'm using classification report, and I want to also use the confusion matrix, so I'm printing a confusion matrix also. So you can see the result. The Navy based classifier is classifying your data, your document, and your 20 documents, and it is giving the accuracy of 0.99, which is 99.62%. And I'm also getting the precision and recall on these two classes, which is AFT.athism and science.space. In these two classes, we have done the classification. So this is all about your text classification. So we have done what we have done. We have taken the data set. We have given, we have imported the data, and we have divided the data into training and test, and whatever pre-processing is required for my data set, we applied the pre-processing, then we have built a model, and then we have predicted the result of our Navy-based classifier on text data. So this is all about your text classification. I hope it is clear to you. Thank you.